Hey, year 11. So, this is exercise 2C. This is assuming that you've completed exercise 2A and 2B. Remember, B was on gradients, and what was A about again, actually? I think that was, let me just refresh my memory. A was distance and midpoint. That's correct. So you had 2A. Let me just write this down so I remember. So you got 2A, distance and midpoint formulas, how to use them, how to solve problems. That was exercise 2A. So the questions I've set, do the questions so that you can ensure you can do any type of questions to do with distance between 2 points. Any questions to do with midpoint. I know the midpoint gets confusing when they tell you to find the y coordinate instead of the midpoint. So it's worthwhile having a look at those later questions of exercise 2A if you haven't done so, or if you've done any of the questions at all. 2B was on gradients. Most students should be fine from this from year 9. I suppose the only tricky questions were the last few questions on parallel lines, which we'll be going through in exercise 2D, or E, sorry, and there'll be parallel lines and perpendicular lines, how to sketch, how to find the equations and whatnot. But for today's exercise, we're going to be going into straight line equations. Okay, so how to identify the gradient, the y-intercept, how to find the equation of a line. I guess that's literally what this says. All right. Anyways, let's begin. So I'll be making videos throughout today. So 2C, 2D, 2E, and possibly 2F, depending on whether I think you guys can handle that amount of work. But you know, if I have enough time, I'll do 2F too anyway. All right, here we go. Equation of a straight line. Remember, back in year 9, you had y equals mx plus c. That's what we call the general equation of a straight line. And what that means is basically any straight line that you can think of, whether it's this line, whether you have this line, or whether you have a horizontal line or a vertical line, every one of these lines has an equation. And that equation will always look like something like this. So I'll give you an example, okay? I'll give you something like, it could be y equals 3x plus 1. It could be y equals 3. It could be x equals negative 2. It could be y equals to negative 2 x. It could be y equals x. All of this is in one way or another this form. Okay, and all of that as well, everything I wrote there, if you type it in your graphics calculator, will end up being a straight line. So it'll sketch a straight line for you. Your job today is to identify what M and C meant and how that affects the graph. You know, so remember we talked about gradient means the slope, the steepness of a straight line. How flat would the line be, and then where is it positioned? I mean, the same gradient could be up here, it could be there, it could be there, it could be there. I don't know where it is. So that's what these two things are responsible for. Okay, so let's have a recap of what mx plus c stands for. So the gradient, which we talked about is in exercise 2b, is the steepness of a straight line. That is determined by the value multiplied to x. So if you have a look at the examples I just had over here, see this is my x value. Whoops, I'm coloring that in. Oops, shouldn't be yellow, should be highlight. This has an x, the value multiplied to x, which is currently the 3, not the 1. See, it's plus 1, not it's x plus 1. So it's not times to the x. What's being multiplied to the x is the gradient. So in our case here, 3 is the gradient for this particular line. If we have a look at the exact second example, well, this one doesn't have any x's at all. So this means that it is no gradient. So it has gradient of 0. This one has gradient of 3. This has, again, x, it does have an x, but x is the subject. And it's not in this form, actually. It's not in this form, but we do know this is a straight line equation. So the question is, what is the gradient for this one? Well, I'll show you that in exercise 2D more in depth, why it's a vertical line, but I'll just give you the answer. When we say x equals -2, remember this is the x-axis, so you have 0, 1, 2, 3, 4. Then -2 would be -1, -2. And because we know that x-coordinate is always going to be -2, well, here we go. This is the line where x is always -2. See, the thing that a lot of students get confused by is when we say x equals -2, they're like, right here. It's like, yes, that's true. And that point there is -2, 0. That's my x-coordinate. So it is true, x is -2 there, but at the same time, I could have, let's say, if this is y-coordinate 1, this point here could be -2, 1. And again, that x-coordinate is still x equals -2. If I drew another coordinate up here and I said 2 is here, then, well, this one would be -2, 2. And again, the x-coordinate is -2. So that's why the line, straight line that cuts through -2 at x, for the x-coordinate, it cuts through all -2s. This makes sense why every coordinate you can think of, all of this will have an x-coordinate of -2, which fits in the rule x equals 2. Sorry, I'm just writing out the coordinates. X equals -2. See, this is the rule. The rule says x will always be -2. So that's why you know the coordinates, x is always -2. And that ends up giving you a straight line that is vertical where x is -2. So what I'm saying in a nutshell again is, this line that comes down, that crosses through the point -2 on the x-axis, that is what the equation x equals -2 represents. Okay, so it is a straight line. It's when the gradient is vertical, and we know when it's vertical, we call that undefined. So if you've forgotten this, this is back in exercise 2B again. Okay, let's go to the next example. Now I've got y equals to -2 times x. Okay, so -2x means -2 times x. So what that implies now is that I have a gradient. To remember, it's m times the x value. So my gradient here is -2. Okay, so m is -2. And finally, y equals x. When we write y equals x, a lot of students look at this and say that the gradient is equal to 0, which is incorrect, because I know that you guys look at it and say, well, I don't see a number. It's true, but if I asked you how many x's are there, you'd say, well, there's 1x. So that means technically this is a 1x. Because when I ask you, what is the number, or how many x's do I have here, you'd say 2. So you say the gradient is 2. And if I wrote y equals 3x, you would say gradient is 3. Which is funny because there's 2 of these x's, there's 3 of these x's, but then when I write y equals x, most students would say m equals 0. How's that logic work? It goes from 3x, which is 3, 2x, which is 2, and then x, which is 0. You know, shouldn't 0 be y equals 0? There's no x's. It's like 0x, and then y equals 1x, and then y equals 2x, and then y equals 3x. See, that makes more sense. This has m is 0, m is 1, m is 2, m is 3. See, it follows a pattern. Makes more sense. True? Okay, so when we don't write the x, when we don't write the value, when we write y equals x, we are implicitly saying that, or we're implying that there is a 1 in front of x. So actually, the correct answer for this equation, the gradient is 1. Okay. Now, let's put all this to the test again. So now we've just talked about the gradient m. So I've shown you different ways of seeing the gradient. And notice it doesn't have to be in this order, meaning you can have y equals to 3 minus 2x, for example. The gradient is not 3 because we just said that it's the value multiplied to x, which is the gradient. In our case here, x is over here. And when you multiply into that, this is a -2 times x. So it's -2 times x. And in short, we write that as negative 2x. So in fact, the gradient for this example here would be m equals to negative 2. Okay? And the last value, okay, plus c, is what we call the y-axis intercept. Okay, so if you remember in your Cartesian plane, you have an x-axis, you have a y-axis. Whatever this value is, that is where it crosses the y-axis. Now, I normally don't like students to just memorize everything I've just taught you so far, or explained or re-explained. But for the sake of doing examples and doing the videos so that you don't watch so much explanation and you just sort of get onto the exercises, just for today, you're going to just know it as the y-intercept. Surely in the next few videos, there will be times where I can explain why that is the y-intercept, but just for now, that is where it crosses the y-axis. Now, this is your y-axis, okay? All of this is your y-axis, right? Whatever that value is, so if I gave you, let's say, y equals to x plus 1, okay, actually I'll do 2x plus 1, then we know that the gradient is 2, and the last value, c, is 1. What that implies is you have, on the y-axis, the straight line will cross at 1. Sorry, that's my phone. I'll just put that away. Okay, so it'll cross at 1, and you'll have a line that crosses through at 1. Okay, so whatever the y-intercept value is, so if it was 10, then you have the line crossing at 10. Okay, rather than 1. And depends on the gradient as well. It doesn't have to look like that. It could look like this. It could look like that. It could look like this. It could look like that. It all crosses through 10. Okay. All right. Now, let's do some examples. Okay. Let's have a look at this one. It says, example 7, find the gradient and y-axis intercept of the line y equals 3x minus 4. And I'm looking at this. I'm like, okay, let's have a look. The general equation for a straight line is y equals mx plus c. We said that any value multiplied to x is the gradient. And the leftover value is your y-intercept. Now in my case here, I can see that it's 3x minus 4. So the 3x is what I'm reading. 3x means 3 times x. So the value times to x has to be 3. So now I know that is my gradient. What's my c value? So c is the leftover value. So c is the leftover value. And I can see that the leftover value here is negative 4. Because it's negative 4, I now know that the y-intercept crosses at negative 4. So what I'm saying here is if I drew this graph, which is an exercise 2D, this is my y-axis. And this is where negative 1 is, negative 2, negative 3, negative 4. This is where it crosses. Now, I don't know where it crosses, or how it crosses it. It could be like that, it could be like this, it could be like that. I don't know what the straight line looks like until I look at the gradient. Now, clearly the gradient's 3, and 3 is a positive value, so I know it's a positive gradient. So it has to look something like this. The problem is I don't know how steep it is. I don't know. It could be really steep. 3 could be a very steep number, or 3 could be maybe a bit more flat. So it might look like this. So it crosses through the negative 4, and it could be a bit flatter, it could be steeper. That's where you have to learn to label your axis intercepts. See, if you got these 2 points correct, then everyone will be sketching the same type of line, if you get what I mean, with the same scales, of course. Okay, but for the first example, all you're doing is writing the gradient and the y-intercept. Okay, I'm just doing this on a slide so that you can visualize it. You're going to sketch graphs in Exercise 2D. Okay. All right, there we go. So the first answer was find the gradient, which I've got, m equals 3, and the y-axis intercept, which is negative 4. Okay. Let's go to the next example. Remember, the whole exercise, I don't care, on the whole chapter, I want you to stick with this formula. Okay, y equals mx plus c is your linear equation. Okay, I don't care what other form the textbook teaches you, just stick with y equals mx plus c for me. Okay, everything you're going to do with straight line equations, you are going to be using you're going to be using this formula, okay? Solving, sketching, everything, okay? Y equals mx plus c. You just need to remember m times the x. What it does to the graph is it affects the steepness. So it makes it flatter or steeper. Okay, that's what the value times x does, this m. And c, while you have all these values here, it can shift it up or down. That's what the y-axis intercept changes. It either moves it up or down on the y-axis. Okay, so it could start here and it ends up there, or it ends up here. That's what c does. Okay, I'll show you that later on. But anyways, let's go to the next example. I feel like I take quite a bit before I move on to the next example, so let's do 2 examples. Okay, all in one. Let's do these 2 examples with the same concept. Y equals mx plus c. So find the equation of a line with gradient -3 and y-axis intercept of 5. So they're asking you to find the equation. So you know that the equation has to be of this form. Why? Because it says line. If it says quadratic, then obviously you wouldn't use this one. But because it says equation of the line, you know it's y equals mx plus c. You know that you need m, which is the gradient, and c, which is the y-axis intercept, and so your answer is literally y equals 2. And they already told you, they said gradient is -3. So you're all right, well, I've got m, -3. They told you y-axis intercept is 5, so you know c must be 5. Okay, so I'm going to go back here, I'm going to write it down. So gradient is -3, so instead of m, I now have -3 times x. Y-axis intercept, which is 5, so instead of c, I have now +5. I'm done. First equation down. Question down. Example 8, okay? Now, example 9, very similar. State the gradient and y-axis intercept of the line y equals 3, y plus 6x equals 9. Now, similar, like I said before, we only ever work in this form. Reason being, it's easier to sketch the graph on your calculator, okay? This is a straight line equation. It's just rearranged, or they made it look different, okay? And your goal is just to get y by itself and everything else on the other side of the equal sign, okay? So this is my goal. I want to make sure my equation ends up looking very similar to this box. Okay, so let's have a look. This is my equation. 3y plus 6x equals 9, right? Now, what's the issue? Why doesn't it look the same? Well, firstly, this has the x on the other side of the equal signs, and right now my x is on the left-hand side rather than the right-hand side. So the only way to move it across, okay, or balance out the equation, so keep the equation the same, but I want the x's on the other side. The only way to do that, if you think about it, I've got positive of these 6 x's. Now the only way to remove it means like you want to cancel it out. You want to make it null or 0. 6x, the only way to make it 0x is if I said take away 6x. It's like if you had $6 in your left pocket, and you want to remove $6, then you'd use $6, or you take away $6. Yeah, you put $6 in your pocket and you take away $6. Yeah. So here I've got 6x, and I minus 6x to remove it, but that doesn't make sense. I just take away 6x. Like imagine you have $6 in your left pocket, and you want to put it in your right pocket. So what you would do is you take the 6x from your left pocket, and it has to go somewhere. So you took away the 6x, that taken away 6x now goes into my right pocket. Okay, so it's like left pocket, right pocket. But it doesn't make sense if I didn't put it in the right pocket. Would be in a case where I've been pickpocketed. Someone's stolen my money. So it's in my, I'm just going to draw a picture so you can see. And draw a picture to illustrate what I'm trying to say. So if this is my pocket here and I had $6, okay? If it's on my left pocket, this is my right hand side. If I didn't take 6, so this is 6x, I remove my $6, so I lose my $6. If I don't put it on this side, well then, obviously I still don't have the $6. So that's why when you take away 6x on one side, you got to make sure you also take it on the right hand side too. Okay, balance the equation. Whatever you do to one side, you do it to the other. Yeah, otherwise it's kind of like someone just taking your $6 and there it goes, it disappears. So that's what I'm trying to say is you can't do this. You can't just say, take away 6x, bam, bam, and then 3y equals 9. See, that's an issue because you just took away the 6x and it just disappeared. You've lost $6 and you never put it back into your right pocket. So what I'm meant to have is not 3y equals 9, but 3y equals 9 minus 6x. That's what I'm meant to have. Okay? So, in the next line, once I've minus 6x on both sides, I get this new line. Okay, so it's 9 minus 6x on the right-hand side. I remove this. This now becomes 0x. So, of course, that all disappears. And I've left with 3y on the left-hand side. Okay? Now, still, I'm not happy because I still want y. I just want 1y. I didn't want 3y. I've got this 3 here. That's an issue. But remember, when you write a number next to a letter, it actually means times. So I right now have 3 times y equals to 9 minus 6x. And the same drill applies again. If you got 3 times y, you want to remove the times 3. We gotta undo it. It's like you know, you tripled it. Then the only way to not triple it or reverse that process is if you share 3. You multiplied it, you share it, or you divide it. Yeah. So if it's times 3, what I'm going to do is I'm going to say divide 3 to every term, or both sides. You know, I'll just do it in one go like this so you can see what I mean. I divide 3 on the left-hand side of the equal signs. I divide 3 on the right-hand side of the equal signs. Now I know that 3 divided by 3 here is 1. And 1 times y must then obviously be 1y. But we normally don't write 1y, we just write y. Yeah? And over here, yes, I know it's a massive fraction. We all hate fractions, don't we? But just going back to primary school and 3 and 4 mathematics, we can actually split this fraction into 9 over 3. See, that's the 9 over 3 minus 6x over 3. Okay? And this is nice because we know that 9 divided by 3 simplifies down to 3. And 6 divided by 3 is now simplified down to 2x. Okay? So that's why I know if I divide both sides by 3, again, this 3 cancels out to be 1, so that's why I have 1y on the left-hand side. And on the right-hand side, this cancels out to be 3 minus, and 6 divided by 3 again is 2x. Okay? So I'm just going to move on to the next line so you can see what I've done here. I divided both sides by 3, and that gives me my answer. Okay? Now, when I say answer, this just means I finally got it into y equals mx plus c. So now to answer the question, which is my gradient and which one's my y-axis. So it says here, state the gradient, state the y-axis intercept. Clearly, the gradient is the value times 2x, which we have -2. And the value by itself, which is c, is +3. Okay, so my answer would have to be m, which is the gradient, is equal to -2, not -2x. That's another common mistake most students do. And the value of c, which is the y-axis intercept, is at 3. Okay, if any of this is, you know, new again, or you've forgotten it, or seems challenging, watch this part of the video again before you keep moving forward. Okay, because they're all of the little essential things you need to be able to identify. So what a gradient is and what's the y-intercept. Then we'll do a couple more questions. Yeah. But all right, from here, I'm going to assume that you've understood how to identify the gradient and y-intercept. So I'm going to do the next few questions a bit faster. Okay, here we go. Find the equation of the line which passes through the point -1, 3. So now I've got a point. So that means when x is -1, y is equal to 3. Yeah, so that's your -1, 3. That's your x coordinate. That's your y coordinate. That's what they've given me. And then they also gave me gradient of 4, so m equals 4. All right, I like to write my information out. So here we go. It says find the equation of a line. Didn't say equation of a quadratic. Didn't say equation of any other thing. Just equation of a line. So I know it has to follow this form. All right. In order to fill out this answer or fill it out, the only way I can do that is if I find out what gradient is and what the y-intercept is. So what I'm given though, luckily, is they already told me m equals 4. Gradient is 4. So I already know this is 4. So my equation should actually already be y equals to 4x. See, the m I know is the 4 now. I just don't know what c is. I still have no idea what that is. That's why I need to find. So the question is, why did they give you a coordinate? Why did they give you the x coordinate and the y coordinate? Why did they give you a point? What's the reason for the point? Well, it says the equation of this line, so this is this line, and it passes through -1, 3. So that means there's a coordinate where it's -1 and 3 on the straight line. Okay, something like that. I just made it up. I'm not sure if this is what the graph looks like, but I'm trying to say that on this straight line, it has, when x is -1, the y coordinate will be 3. So this is interesting because in your equation over here, you have an x coordinate here. You have a y coordinate here. And what you know is if this was -1, if x was -1, then y has to be 3. Because it passes through that point. The straight line has that fact. Like the fact is, this straight line, when x is -1, y is 3. So that's what I'm going to do. I'm going to substitute these values in to see if I can find out what c would be. Because it says here, 4 times whatever x is, plus whatever this number is, should give me this answer. So if I got 3 here and 4 times a -1, so let's write it down. So I'm saying, all right, so the answer has to be 3. I've got 4 times -1, which is actually -4, plus c has to equal to 3. Now we can count with our fingers. We can say -4 plus something has to equal to 3. So this is the something I'm looking for. So if you think about a number line, -4 is over here. You got to plus something, so you don't know how much you add until you get to 3. So if you think about it, -4 all the way to 0 is 4 jumps. And then from 0 to 3, that's another 3 jumps. So how many units have you moved all in total? That's 7. So you know that -4 plus 7 will give you 3. So, you know, the y-intercept has to be 7, logically, right? But we don't like doing that. What I just did there is your primary school sort of hopping, or year 7, you know, we don't use algebra here. But up until this point, we can use algebra. Just like before, balancing the equation, minusing 4 and plusing 4. So this is -4. You can see to remove the -4, I add $4, or add 4, and then add 4 on the left-hand side as well. So you can see if I add 4 on both sides, -4 plus 4 cancels out to be 0, and 3 plus 4 is 7, and I'm left with C. Just like what I did before with the number line, I figured out it was 7. Well, now I don't have to do a number line. I figured it out algebraically. C equals 7. Okay. Now I'm just gonna make it a bit cleaner. So this is what we did, and then we got our answers: 7 equals C, 7 equals C, or C equals 7. Yeah. So just going through here again, this was times. I substituted -x in, 3 in, to where the y is. I times them, I get -4, and I said +4 on both sides. -4 cancels out and becomes 0, so I got C left on the right hand side, and 3 plus 4 is 7. So what does that mean? That means my equation is now, I already got M, which is 4, and C, I just figured out, was 7. So if you answer the question, gradient, because this says find the equation of the straight line, I've got the equation of straight line right there. It's got the gradient of 4, and C equals to 7. Okay, I'm going to do the same thing for example 11. Okay, so let's have a look. Find the equation of n line. Same thing again, equation of the line, always use y equals mx plus c. That passes through, so there's the straight line, and it passes through 3, 2. So if you think about it, wherever 3, 2 is, this is 3, let's say 2 is here, so this is your coordinate, 3, 2. There's a line that passes through that, so it could be like that. This could be my line. This could be my line. I don't know which one it is, okay? But they also tell you again, gradient of -2. And this coordinate here, when x is 3, y is 2. Yeah? All right, so same process again. I've got -2 as my gradient, and I've got the point 3, 2. So the first thing I already know is m is -2. I'm going to write that down. Y equals to -2 times x plus c. Okay? So the problem is I still don't know what c is. I don't know what the y-intercept is. But no worries. I know when x is 3, y is 2. So that's what I'm going to do. When x is 3, y is 2. I'm going to write that down. So here we go. We got y is 2. We got -2 times x, but x is now 3. So negative 2 times 3 is negative 6. I still have the plus c over here. Okay, so I rewrote it, negative 2 times 3, that simplifies down to negative 6. Now from here, I want to find what c is. So the only way to get c is if I remove the minus 6. That's an issue. On the right-hand side, I've got negative 6 plus c, and I don't want that. I want to remove that minus 6. So the opposite of minus 6 is? Yeah, hopefully you're sort of saying it in your head. You say plus 6 on both sides, because, you know, that's the inverse or the opposite of minusing 6. And we can see that minus 6 plus 6 will cancel out to be 0. Okay, and then 2 plus 6 is 8. And that leaves with c on the right-hand side. And now I know y equals mx plus c. M, which they already told me, was negative 2. And c, we know, is 8, because we just figured that out. Okay, so answering the question, I'm just going to remove all of this so you don't get confused. We now know 8 equals c. And therefore, I can say now, m, which is negative 2, c, which is 8. See what I'm doing there? It's the same drill. Same drill. Example 11, example 10. Similar concept. Yeah? Hopefully we're feeling pretty good. Let's try the next few examples again. Same idea. Okay, now again, if you've had a look through the video already and you're replaying it and whatnot, so hopefully you've gone through this, you understood how to find m, how to find c, and then in this next slide, you now know if I'm given a gradient and given a point, how can I solve this puzzle? Remember, it's all a puzzle. It's all a puzzle. The questions only change it by giving you different pieces of information. They might give you gradient, and they might give you the y-intercept and say, find the coordinates. You know, like if x was negative 1, what would y be? They might give you a coordinate and the y-intercept and say, find the gradient. Something like that, okay? So I'm assuming the next slide is what it does. So here we go. It says, again, find the equation of a straight line. So you know, again, it's y equals mx plus c. It passes through the point c. Now, this is different compared to the last example, you see. They don't give you the gradient now. Now you need to find the gradient. They've only given you 2 points. Okay, and so you're going all the way back to b again. How do you find the gradient of 2 points? Okay, now you can do this multiple ways. You can draw it out if you want. You can have 1, negative 2. So let's say this is where 1 is. Negative 2 is down here. So this is my first coordinate. This is 1, negative 2. and you're looking at 3, 2. So let's say that's 2, that's 3. And 3, 2, let's say it's about here. So 3, 2 is over here. So the gradient means a straight line passes through these 2 points right now. Okay? I'll draw a different color so you don't get confused. There we go. Okay, so I got my straight line. Looks something like that. My job is to find the gradient first because I have nothing at this moment. I don't know what the y-intercept is. I have no idea what that is. I don't know what gradient is, but I know I can find it because from 2b we knew it was rise over run. Which really just means like from this first point to the second point, how much did I go across and how much did I go up? That's what I want to know. Okay, from one point to the other, how much did I rise and how much did I run? Now you can do it that way, or you can use that rule that you learned in exercise 2b, y2 minus y1 over x2 minus x1. Okay, and that's what I'm going to do. I'm going to say now, I know the gradient is take any of the coordinates, take the y coordinate minus the y coordinate, and the x coordinate minus the x coordinate. All right, and I happen to call this number 2 and this number 1. It doesn't really matter which one you do, and whether you do 1 take away 2 or 2 take away 1. It'll end up being the same anyway. Okay, so in my case, I chose 2 take away negative 2. So I looked at the y values. So this is my y2, y1, so y2 minus y1. So 2 minus negative 2, that's what I wrote here, minus negative 2. Yeah, and then I got x2, so this is my x2 minus x1. So 3 minus the 1, and that's what I have down here. Okay, and so that simplifies down to, now remember 2 negatives make a positive, so 2 plus 2 is 4. And then 3 minus 1, which is 2. But then 4 divided by 2 is 2. Okay, so what that tells me now, from the 2 coordinates, I've just figured out m equals 2. I've got this one. The only thing I need now is c. And that's going all the way back to the same example as the last one. See, I've got a point here and I've got a gradient. Well, in our case here, we're fortunate. We have 2 points and a gradient. You can choose any point. Doesn't matter which one. Okay, so if you think about it, this is my equation. I'm just going to remove all the pictures and everything. Okay. We just found m is 2. We've got 2 coordinates. We've got when x is 1, y is negative 2. Or we have when x is 3, y is 2. I mean, when x is 1, y is negative 2. And when x is 3, y is 2. You can choose any of those points. It doesn't matter because we just need an x and a y. I'll show you. I'll show you if I do both. Okay, so let's say x is 1. I'm going to do when x is 1, y is negative 2, right? Let's substitute that in. So 1 goes here because that's where x is. And y is over here. So this now becomes negative 2 equals to 2 times 1 plus c. 2 times 1, which we know is 2. This is still negative 2. And this is still plus c. And then we say, well, I want to find c. So you've got to remove the positive 2 here. So how do I remove the plus 2? Opposite of plus 2? Yes, hopefully you got it right. Minus 2. So I minus 2 on both sides. 2 minus 2 is 0. Negative 2 minus 2 is not 0, it is minus 4 equals to c. Okay, so what that tells me, c is negative 4. Now let's show that it doesn't matter which coordinate I chose. See, the first one I chose was 1 and negative 2, and I got the answer as c equals negative 4. Let's say you didn't do that. Let's say you chose this one instead. Let's say you chose when x is 3, y is 2. All right, so my equation here, I would now have 2 is equal to 2 times 3 plus c. See the difference? Instead of times 1 and then minus 2, because that's 1 and negative 2, now I have times 3 and it's equal to 2. Yeah, so let's work this out. 2 times 3, which is 6, plus c, and I've got 2 there. And now, same thing again, I have positive 6. The only way to remove the plus 6, minus 6 on both sides. Okay? 6 minus 6 is 0, and 2 minus 6 is negative 4. See? Same answer. Doesn't matter which coordinate you choose. You just took an extra step because you had to find m. Whereas in example 10 and 11, they gave you m. See what I mean? You're just problem solving. But at the end of the day, you're using only one rule. Y equals mx plus c, and you're using anything you learned from exercise 2b. Yeah, and you're putting in. That's what exercise 2C is about. Yeah, let's do the next one. Same concept. Okay, same concept. I'll just remove all of this. There we go. Same concept. Okay, so example 13. Find the equation of a straight line with y-axis intercept of negative 3, which passes through the point with coordinates 1, 10. Okay, so if you follow that same thing again, what have they given me? This time they gave me equation of a straight line, which we know is this. Yes. They gave me y-axis intercept, which is negative 3, and it passes through this corner. So they gave you a coordinate and a y-intercept. So this is what they've given you, y-intercept and a point. They didn't give you m. Now your job is to find out m. Okay, so see what I mean? It's just a problem-solving thing. You just play around with the numbers and try to use algebra to solve m, c, or a coordinate. So if I were to fill this out, same thing again. C, I know, is negative 3. I don't know what m is. M times x, I don't know what the value of m is. But I do know when x is 1, y is 10. So that's what I'm doing. I'm putting x is 1, y is 10. So that's what I do. I follow that, and it says m times 1, which we know is m. And you got minus 3. And now, same drill again. We're trying to find out what m is. We don't want to know what m minus 3 equals to. We want to know what m equals to. So we've got to remove the minus 3. Now, minus 3, opposite of minus 3, we know that instead of minusing 3, we can add 3. That will make it 0. So if I say add 3 on both sides, okay, then now minus 3 plus 3, we know is 0. And we've got now m is equal to 10 plus 3, 13. So now I know the gradient. So if I know the gradient is 13, and I know the c, which they told me from the beginning was minus 3, I've got myself an equation where it's y equals 13x minus 3. Okay? And you can test if this is true, because if you substitute 1, apparently the answer should be 10. So you can see 13 times 1 minus 3. Let's see if y does equal to 10. So 13 times 1 is 13. minus 3. Let's see. Y equals 13 minus 3. Yeah, there you go. See, it makes sense. Because that's the rule. This is the rule. This is a coordinate. When you put in an x coordinate, you're meant to get the y coordinate. Yeah? And we just tested it. It's true. So that's why this is my rule. This is my equation. Whatever x is, times it by 13, then minus 3. That will tell you the y coordinate. Right? There you go. So that's how to solve the equations of a straight line. Okay, that's how you solve the equations of a straight line. Hopefully I've done it in depth so that, you know, while you're watching it, you're sort of understanding the drill. Practice it, okay? Because remember, I'm going to be away Monday, Tuesday, Wednesday, and I think it was the Wednesday that I have a double session. So there's quite a bit of catch up, and I do want 1C to be down. 2C and 2D to be down. 2E and F, you know, I can sort of pick it up when I come back. Ideally, I still want you to have done them as well, or at least work with them, or have an idea, or have seen the video. But there you go. That's how you do 2C, finding equations given all these different points. Okay. Now let's go on to the second part of your exercise 2C. You got vertical and horizontal lines. Now, when it comes to vertical and horizontal lines, okay, they all have an equation. They're all straight lines, so they have to have an equation. Now, remember at the very start of this video, I talked about vertical lines having a gradient of undefined, which I explained in exercise 2B why we call that the undefined. If you forgot, I'll remind you. If I had $1 and I don't know who I was going to share it to, then, you know, I think I was talking to Ryan at this time. I was saying, if I had $1 and I didn't know who I was going to share it to, well, then you don't know how much I'm going to share it by or how much you're going to get, because you don't know if I'm going to give you money or not. Whereas this one over here, this one, you know, I've got $0 and I'm going to share it to Ryan, and then 0 shared one person. And so Ryan will obviously get $0 because I have 0. Yeah. Same concept here. What you have to remember here is, well, if your equation of a straight line is y equals mx plus c, if m is equal to 0, well then what would you have? You got 0 times x plus c. So 0 times x is 0. So you end up with y equals c. Okay? And that's why when you ever get an equation, for example, this line here, y equals c, well, the y to c is your y-intercept, and this intercept here is at 2. Because it's at 2, that means I know the equation here has to be y equals 2. Gradient is 0, because it's a horizontal line. Horizontal line is when gradient is 0. Okay? Whereas vertical line, I don't have any y-axis intercept. It doesn't have any c's. C equals, like, I don't know, it doesn't cross through the y-axis. But I do have an x-axis intercept, which is at 3. That's why this is the equation of a vertical line. So anytime you have x equals anything, that's a vertical line. If you have y equals to a number, that is a horizontal line. Okay, so let's take a couple examples here. So this is from exercise 2C. I've got question 12, E and F. So if you have a look at this, these are horizontal lines as well. And I'm looking at this and I'm saying, well, horizontal line, that means gradient 0. This is a vertical line, so m is undefined. So the first thing I know is that this has to be y equals a number, which is my y-axis intercept. And that's about, what, 3.5 maybe? So it's 3.5. And then you look at question F, it has to be x equals 2, because it's a vertical line. So vertical lines don't have c's. See, the vertical line, this red line here, doesn't cross through the y-axis. You see that? It doesn't cross through the y-axis. So you can't have a c, and it has a gradient that is undefined. So what do we know? We just know that it's always crossing through -2. Okay. So the rule is saying x will always be -2, which is true. See, this vertical line here, if I chose a point on the line, this point here would be at -2, 3. If I chose this point here, you would say it's -2, 2. If I chose this point here, you would say this is -2, 1. So what's the common rule here is x is always -2. That's what this rule is saying. Okay, so if you drew a table of values back in year 7 and 8, you would have had questions where they're like, fill out the table of values. So when x is, if you always know x is -2, okay, so x is always -2, that's what this rule is saying, x is always -2, then y could be anything, because it doesn't say anything about y, so it could be 1, 2, 3, 4. And if you plot that on a graph, See, negative 2, 1, negative 2. This is where negative 2 is. 1 is here. Negative 2, 2. So negative 2, 2. This is negative 2, 2. And then 3. And then 4. And what you can see is, of course, it's a vertical line. That's what you did in year 7 and 8. Yeah? And then year 9, you played around with the equations, which is what we're actually doing right now. This is year 9 sort of manipulation there. But that's exercise 2C. How do we feel? Hopefully we feel all right. Yeah? I forgot how long or when I started recording this video, but it's probably about half an hour. So well done for watching all the way to this end. All these questions are variations of that. Okay, so if I briefly run through exercise 2C question 1, so if you look, state the gradient, y-axis intercept. Again, gradient is 3, y-intercept is 6. Gradient is negative 6, y-intercept is 7. By the way, I don't want you to write this in your exercise books like the way I'm doing it to you right now. Okay, I want it laid out. I want to see it like, you know, I want to see question 1a, y equals 3x plus 6 in your exercise book, and I want you to say m equals 3 and c equals to 6. Okay, I want you to write it properly. Yeah, don't do what I'm just doing right now. I don't have space and I'm just showing you what I mean. Yeah. Okay, question 2, you can see find the equation in a straight line. They give you the gradient and they give you the y-axis intercept. So that's pretty easy. You know, it's like y equals to mx plus c. They told me the gradient already, so that has to be 3x, and they told me the y-intercept is 5. Done. Okay, so that's question 2. You go on to question 3. The problem is they're not in y equals mx plus c form, so you have to rearrange it using algebra. Okay, so for example, the first one, I would say like, I like to, because I don't like negative y's, so what I would have done is, I'm just going to write it over here. Okay, I'm just going to move this over here. 3x minus y equals 6. How I would have done it is I would have said, well, that's a minus y. I don't like negative y's, so I'm going to do plus y plus y. See, that's perfectly fine. There's nothing wrong with adding y's. Negative y plus y, 0. It was like saying negative 1 plus 1, or negative 2 plus 2. It cancels out to be 0. So what do I have now? I have now 3x is equal to 6 plus y. Right? But I don't want 6 plus y. I just wanted y. Y equals to something. So I need to remove the 6. So here we go. We say, all right, well, to remove the 6, I'm going to say minus 6. Minus 6, because that's a positive 6. 6 minus 6 is 0. That's 0. Then my right-hand side, I only have y. Left-hand side, I have 3x minus 6. That's my equation. See, I've got y. Y equals to this. Well, you can rearrange it if you like it to look at it like this. Y equals to 3x minus 6. Same thing. Yeah? And so now I know the gradient's 3, y-intercept is negative 6. Okay, so gradient's 3, y-intercept is negative 6. Okay? So that's question 3, rearranging. Question 4, same thing, rearrange. Question 5, they gave you a gradient and a coordinate, substitute and find c. Question 6, they give you 2 coordinates, find m and c. You see, it's all the examples I've done, and that's what I want you to do for 2C. Okay, they're all doable. Thanks for watching the video. Continue doing what you're doing. You're doing very fantastically. I'm really proud. I wish I was there to help, but you know, I'm on camp on Monday to Wednesday, and you know, we've got to take care of the youngies, and I'm doing my best right now to take care of you guys. Okay, so please do the questions. Please do. You don't need to do all. Remember that. I'm trying to assess whether you understand everything I teach. Okay, so for example, 2A, distance formula, midpoint formula. Can you do all types of questions with it? When I say all types, I mean like, you know, can you do it easy, hard, medium? That's what I want. Okay, I want to know that you've ticked off 2A. 2B, do you know what a gradient is? Can you find the gradient? Can you solve any types of gradients? You know, that's what I want. How many types of gradients are there? That's what I'm looking for, 2B. And then 2C is like everything I taught today. Could you play around with all questions? You see, this whole exercise was only to do with y equals mx plus c. And they've just given you many different ways of solving for m or c or the equation. And so that's what I want you to do for exercise 2C. The questions I set is a guideline. You know, like I think this should be enough for you to sort of understand. If you feel that you need to do more, by all means, do more. If you feel like you need to do less, by all means, do less. I don't care how you do it. I just need to know when I test you, when I give you an assessment, or when I test you in class, when I say, hey, you, how do you do this? Blah, blah, blah. You know, and if you can tell me, then that means you've successfully done what I wanted you to do. Yeah. So you are now in senior level. You are on your own in terms of choosing how you want to study. Yeah. I'm not here to babysit you. I'm here to guide you. I'm your teacher. I'm here to help you when you need, but you don't need to follow everything I say like a robot. Okay. You got your own mind. You can think. And if you know that you know it, great. Move on. Yeah. I will just do quizzes in classes so that I can tell what you know and what you don't know, where you're still struggling. That's for me so that I can learn to improve you. Yeah. But at the end of the day, these exercises, it may seem daunting. There might be a lot. You don't have to do them all. It is for you to choose and understand. Don't cheat yourself. You know, there's no point cheating yourself. You can cheat me, but you can't cheat yourself. Yeah. You can lie to me and everything, which I don't like. But at the end of the day, it is for your own benefit. It's not for me. Yeah. Okay. So yeah, do as many as you can, or as little as you can, or want, as long as you understand those three concepts I've taught you so far. Okay. Distance and midpoint formula. What a gradient is. Now today, how to find the equation of a straight line. Okay. Thank you. Now on to 2D, how to sketch.